you're going to be asked a whole lot of real world questions. Let's read this question number 1. Actually, 1 and 2. Draw a normal curve and fill in the values of the mean, plus or minus 1 standard deviation, 2 standard deviation. Okay, this is the question here. Suppose you are a dog trainer, or you take your dog to animal hospital. They will be doing this. They use normal curve to do a lot of things, including any hospital. Okay, the lifespan of a dog is normally distributed. So anytime I'm told normally distributed, I draw a normal curve. I want you to know that the normal curve I'm drawing is not a standard normal curve, because they give me a mean of a raw data. The mean is 12.5 years. So the lifespan of a dog is normally distributed with a mean of 12.5 years and a standard deviation of 2 years. So I'm going to assume that this question is from a normal distribution. Standard deviation is all right, and mean is 12.5. All right. So, in other words, if a dog weighs 1 standard deviation above the mean, it is 12.5 plus 2. So a dog that weighs 1 standard deviation above the mean is weighing 14.5. If a dog weighs 2 standard deviations above the mean, then the dog will be weighing 16.5. Well, if a dog weighs 1 standard deviation below the mean, that dog will be weighing 12.5 minus 2, 10.5. If a dog weighs 2 standard deviations below the mean, then that dog will be weighing 8.5%. Okay, now I'm going to change this to standard normal. So I'm going to draw my standard normal here. I already know that the mean is 12.5. By the way, since I want to find the z-score of mean, I already know it's going to be 0, but value 12.5 minus 12.5 divided by 2 is 0. So the mean, if I standardize the mean, that's the question. The question told me to standardize it and put it in standard normal. Standardize the raw normal distribution and call it a standard normal. So this is 0. 1 standard deviation above the mean, I already know it is, this is 1. I already know it's 14.5. 2 standard deviations is 16.5. 3 standard deviations is 18.5, and so on. 1 standard deviation below the mean is 10.5, negative 1. 2 below the mean is 8.5. 3 standard deviations below the mean is 6.5. So this is 3 though. So this is a standard normal because I standardize the raw value, standard normal. This is just a normal distribution. So I want to make sure you know the difference. I want to let you know that even if you are trying to do calculus, this is in calculus. That time you will be using integration to find the area under the normal curve. You're going to be integrating on the integration area on that normal curve. And after some time, they ask you to use it statistically, which means you should know. But if you know how to use your calculator to do what we're doing, well, guess what? You ace the test. Unless they tell you to show your work, your integration step by step, you ace the exam. Okay, we did number 1. Let's do number 2. I'm trying to tell you that the knowledge of normal distribution, you will see it in uh, SAT, ACT, you will see it in any exam you're taking. You see it in electrical engineering exam. You will see it in any exam you're taking. So they use normal curve to do a lot of things in life. Let's answer question number 2. Light bulbs. You see, so engineers use normal curve. The reason why I'm doing real life examples of normal curve, I usually do it because really normal curve is the beginning of statistics. Normal curve, remember, you see, we talked about skewed left distribution, skewed right distribution, uniform distribution. It stops in unit 1. Those skewed distributions, they stop in unit 1. Well, now we start talking about normal distribution. When we get to uh, inferential statistics in chapter 7, then it's going to be an extension of normal distribution. But you have to understand the basic. This is the basic standardization of a normal curve. And do you know the difference between a normal curve and a standard normal curve? You have to know the difference. The standard normal is standardized with z-score. The ordinary normal curve is not standardized because some people, even some teachers, we make mistakes though. Okay, so be careful. All right, so now I am given the lifespan of a certain type of a light bulb with a mean of 5,000 and standard deviation of 150. See, these are raw scores. But these, who will be building light bulbs? Engineers. So engineers need normal curve too. Estimate the probability that this type of light bulb has lifespan between, I want you to know that probability, whenever you hear probability about a normal curve, is area under the normal curve. Area under the normal curve is also called probability. So very soon we shall be calling the probability. Another thing we call probability is relative frequency. Relative frequency is probability. Area under the normal curve is probability. All right, so and then I am going to draw the figure. Any question on normal distribution, please draw a normal curve. So I draw a normal curve. Remember, the tails go to infinity. They're not going to touch the horizontal axis. They are asymptotic. Asymptote. They are running horizontally to the right and to the left, to infinity, positive infinity to the right, negative infinity to the left. So the normal curve is asymptotic to x-axis, the same thing as t-distribution. Very soon, when we get to chapter 7 or 8, we'll talk about the t-distribution. Okay, so this is just a normal distribution. Anyway, so I will put the mean. The mean is the line of symmetry. It divides the normal curve into 2 congruent parts. So, and I'm given that the mean is 5,000 hours. The mean is 5,000 hours. And one standard deviation is 150. So this is easy. Let me ask you this one, because if I keep doing it, I'm not helping you. Okay, if one standard deviation is 150 hours and the mean is 5,000 hours, how many hours is one standard deviation above the mean? How many hours is one standard deviation above the mean? Anybody? Anybody can answer so that let me see if we are following. So one standard deviation above the mean is mean plus 150. Mean is 5,000 hours. One standard deviation is 150. So 5,000 hours plus one standard deviation is 5,150. So one standard deviation above the mean is 5,150. All right. What is one standard deviation below the mean? Anybody? Unmute yourself and say it. Unmute yourself and say it. It will be 4,850 because this is one standard deviation below the mean is 5,000 minus 150. So 4,850 is one standard deviation below the mean. Okay. Find the two standard deviations above the mean. So all you have to do is multiply standard deviation by 2. 150 times 2 is 300. 300 plus 5,000 is 5,300. Therefore, two standard deviations above the mean is 5,300. Another question is, what is 3 standard deviations above the mean? You multiply 150 by 3. That gives you 450. 450 plus 5,000 is 5,450. 5,450. And so on. Okay, but the question told you to draw a standard normal curve and put your answer. Well, guess what? Since this is 5,000, the mean is 5,000. I just put 0 there because I know that if I standardize it, I'll get 0 anyway. One standard deviation above the mean, I already know it is 5,150. I put 1 here. 5,300 is 2 standard deviations above the mean. 5,450 is 3 standard deviations above the mean. I complete it like this. Any place below the mean is negative. So whenever you standardize the raw scores, this is the standard normal. Standard normal distribution. The mean is 0, standard deviation is 1. This is a normal distribution, just a normal distribution. Just a normal distribution. Okay. All right. So the next thing we are going to talk about is number 3. How do I calculate? We are calculating with calculator right now. Let's just do it with calculator. Because if you know how to use your calculator, it's an advantage, a big advantage. By the way, why did they require a calculator in this class? They know that it will help you out a lot. So, any question on normal distribution, you have to draw a normal curve. So here, they want me to find the area between. So I have to draw a normal curve first. Find the area between. I'm going to put this in the blackboard so you can use it to practice. Our pre-test will be open tomorrow. Very early in the morning, about 6 a.m., pre-test will open. Remember, I said pre-test is something like practice test. It's not a big deal. When you finish it, it's going to be homework. But the essence of giving it is to make sure you practice it. It's going to look like the test. So on the 17th morning, the actual test will open. The actual test will open. Okay. All right. So this is standardized because the mean is 0. So all these numbers are by the way, they give me z equal to 0. Anytime you're given z, it is a standardized normal. So they give me z. Z means z score. So z is 0. They want me to find the area. Forgive my crooked lines. Z means 0. Z equal to 0 means the mean. So they're asking me the area between 0 and 1.28. I want you to note that 1.28 is positive. Therefore, it is on the right-hand side of the normal curve, or the mean. 1.28 is on the right-hand side. That's why it's positive. So I'm told to find this area, the shaded area. My calculator is a wizard. So I just get my calculator and put it in. The answer shows up. But you can read the chart too, which we will do later. But I just don't want to be introducing something new every day. So let's finish with how to. We already know how to do Z-score today. We know how to do empirical rule the other day. So let's marinate both of them so that by Friday we shall be reading the chart. Okay, so I'll pull my calculator up and go to distribution and find the area under the normal curve between the mean and z equal to 1.25. So how do I go to distribution? If you got your calculator, watch what I'm doing. Second distribution, normal CDF is 2. Now it's asking you, what is the lower bound? This question is asking you 0 and 1.25. Which one is smaller? Of course, 0 is smaller. The upper bound is 1.25. 1.25. The mean of a standard normal is 0. The standard deviation is 1. Best. By the way, let me write the argument again so that you will know. So it's normal CDF, normal cumulative density function, lower bound 0, upper bound 1.25, the mean is 0, the standard deviation is 1. So that is the argument I just typed in my calculator. So I type that in, and it's asking me, do I calculate? I'll say yes. Is this really what you want to calculate? Do you want to calculate area between the mean and 1.25? Yes, that's what I want. I hit enter. It told me that the area under the normal curve, let's put it in decimal. The area under the normal curve is 0.3944. I'm rounding it to the nearest 10,000. Nearest 10,000 is the same thing as 4 decimal places. If you're told to round your answer to the nearest 1,000, 1,000, 3 decimal places, nearest 100, 2 decimal places. Remember, my lab maths will ask you that. Okay, even though it's what you learned in elementary school, but the no knowledge is a waste. Okay, so I'm going to write my answer to the nearest 1,000. It is 0.3944. So the area between this is 0.3944. What if I'm told to write my answer in percent? It is 39.44%. Therefore, the area between the mean and 1.25 is 39.44%. So remember that normal curve, area under the normal curve, probability, relative frequency are the same. So they could ask you to find the probability in decimal or the probability in percent. Okay, we have done between a lot. Let's find area to the right. Number 5. Let's find the area to the right. Area to the right. We already found that the other day on Friday, but I want to let you know that from unit 3, you should be able to find area to the right all the time. The first thing to do is to draw a normal curve. For any question on normal distribution, draw a normal curve. Well, the next thing you want to ask yourself is, the number I'm given, should it be on the right-hand side or left-hand side of mean? It should be on the right-hand side because it's positive. So it's a standardized score of 2.5. 4. So I'm finding area to the right. Remember that this is going to positive infinity, asymptotic to the x-axis. So, and your calculator does not understand infinity. It understands 1e to the power 99. So I'm finding the area to the right of 2.40. So I'll get my calculator again. Between 2.4 and positive infinity, which one is greater? This time the lower bound is 2.4, so I'll go back. See, I'm doing this a lot of time. I'm repeating myself, but I'm recording this, so just know that you can go and watch it again. Normal CDF because I'm looking for area. Normal cumulative density function. The lower bound is 2.4 because it's lower than infinity, positive infinity, smaller than infinity. Okay, the upper bound is positive infinity. I want to make sure you know how do I type 1e to the power 99 again. I want you to be doing it like I'm doing it now. 1 second. Where do I get that e? The e is above comma. The e is the double e above comma. 1e to the power 99. Did you get it? Hopefully, but I'm recording it though. The mean of a standard normal is 0. Standard deviation of a standard normal is 1. Paste. And then I hit enter. The area is actually tiny. The answer to 4 decimal places is 0.0082. If I'm told to write my answer in percent, it is 0.82%. The area under the normal curve to the right of 2.4 is 0.82%. I told you I'm going to put this. This is a practice worksheet. I'm going to put it in Blackboard. Okay. All right. So this question says find the area to the left. The same argument, the same kind. So I'm going to draw the area, a normal curve with area to the left. We did it before. We did it on Friday, but it doesn't hurt to do it again. And by the way, what kind of normal curve did I just draw? That is crooked. That's actually skewed. I'm sorry. Okay, so now I'm going to draw a normal curve. All right, so, and I'll show that it's a normal curve because the mean is in the middle, but I don't need the mean though. I don't need the mean. I am told to find area to the left of negative 0.46. So got to be careful. Whenever you see z negative, it means that z is on the left-hand side of the mean. You don't miss this. You cannot miss this. Minus 0.46. Whenever a standard score z is negative, it's on the left-hand side of the mean. So I am looking for area from negative 0.46 to the left. All right, and negative infinity is written as negative 1e to the power 99. So I'm ready to calculate the area to the left of negative 0.46. I pull my calculator off. Pull my calculator up. Remember that if you can use your calculator accurately, actually the test in my lab maths tests your speed and accuracy. Test in this class tests your speed and accuracy. In other words, that's why they provided the calculator for you. The knowledge of how to use your calculator will increase your speed and accuracy, and you will be doing very well in the test. All right, so I want to find the area to the left. And I want to remember that the negative infinity is negative e to the power 99. So I have second distribution. And by the way, it's good to let me write the formula. Let me write that formula. So I am going to write the formula. So you see, normal CDF, lower bound. Lower bound is negative infinity. And negative infinity is negative 1 e to the power 99. Upper bound is negative 0, 146. The mean of a standard normal is 0. Standard deviation of a standard normal is 1. So I'm going to calculate. And then I'm already in normal distribution number 2. Okay. So I want to tell my calculator that the lower bound is negative 1 e to the power 99. So you go to negative in parentheses, 1. How do I get e? Second comma, then 99. Upper bound is negative 146. If I arrow down, meaning 0, standard deviation is 1, I'm going to paste. So it's asking me, do you really want to find the area from negative infinity to negative 0.46? Yes. I hit enter. And it's telling me that the area to 4 decimal places is 0.3228. Area to 4 decimal places is 0.3328. One thing you must remember is that area cannot be negative. Even if it is area to the left, area cannot be negative. Okay? So even though the z-score is negative, see that the area is still positive. All right, so the area is 0.32276. 0.32276, that's the area we found now. Okay. So now we now know how to find area between, area to the right, area to the left. We know how to do it using application to real life situation. Suppose you are an engineer that builds bulb, or suppose you are a doctor, okay, that looks after dogs. You want to use normal curve to find the lifetime of a dog. If you are a teacher, you want to use the normal curve to find how your children are doing. What is the standard deviation? What can you standardize? By the way, if you're a teacher and a child brings a grade in for English and scored a 90 in English, and brought another grade in math and scored maybe 75 in math, it is not right for you to say, oh, why didn't you do well in math? After all, you made a 90 in English. Because really, you cannot judge the two grades. The only thing you can do is standardize. Standardize the English score, standardize the math score. You should compare things with this score. If you have to do comparison, you must use this score. Because it could be that actually, even though she made a 75 in math, she could be the best. She could have made the best grade. Even though she made a 90 in English, probably everybody in the class made 100. And she could be having 90 as one standard deviation below the mean. So, as a statistician, you're advised not to compare two things unless you standardize them. even if you're not a statistician. As a student who have taken statistics, you cannot compare two numbers, two quantitative variables, different, unless you standardize them. Okay. Let me give you I know our time is coming. We got 10 minutes more, but I want to give you, that next class when we come in, I'm going to start from this worksheet again, because there are some part of this worksheet that we need time to talk about. Because they will actually, if you look at the questions below, they can actually give you a shaded region, a shaded normal curve, and ask you to interpret it. They can actually give you area inside the normal curve and ask you to interpret it. So we are going to be talking about this. So I'm not going to be in a hurry to. I'll put this worksheet in Blackboard. Blackboard.